Today I'm going to show you how a neutral switch works and how I've modified one to detect all gears. This is a neutral switch off a Suzuki LT F250 or 300, whether it's the King Quad or the Quad Runner, they both have the same one. This one has a patched up, it's patched up in some way. I've just taken this off the engine and bored it in to examine it and clean it up. So you're seeing it's just held on by a couple of Phillips head screws. It's got one single wire running to it, a blue one that runs through a bullet head connection. I've got this one tied up with a cable tie at the moment, and there's this big blob of silicone on there for some reason. To be honest, I'm not even sure whether this one works. There's probably no reason why it wouldn't work. The way it operates is there's one single brass contact on the back of it there, on this back plate, and there's a spring-loaded pin that when it makes contact with that brass pin, that brass pin's connected to that blue wire. It shorts that blue wire to ground, or to the engine effectively, so it grounds out that blue wire. This spring-loaded pin is in the end of the barrel that rotates that selects the gears, and right around the end of its travel, in its final position, it's the neutral position, and it lines that pin up with that brass pin, the spring-loaded pin here with the brass pin, making the ground connection. The rest of the time, the green neutral light up on the dash is off. So it's a pretty simple switch or sensor, if you like. Barrel with the fork slots in it. A pin goes in there which registers on a switch that bolts on here, showing where the neutral position is. It pulls and it pushes as well, but it's not pushing. I can't make it push with one finger, I can make it pull. So you can see that's indexing that barrel around, and that's how the sequential system works. Doesn't normally do a full turn, it does nearly a full turn, because from neutral through to fifth gear, and then it's got to go back the other way. I can keep pulling it around there. So this is the barrel, and these are the two sequential gearbox shafts. You see the traces on the barrel here are what the selector forks run in as the barrel clicks around. See how it clicks like that? This is the reversing groove at the bottom here, and that's the neutral position at the end of the run of these other traces. This track here in the barrel, you can see around this way, it doesn't vary. It's flat all the way there, and the dog here is not engaged up or down, so those shafts are rolling together as if it's in neutral. Now as I roll that around, and it wants to go down there. Now it's not going down because nothing's moving, but if I move it, there it did pop down. You see, I don't know whether you saw the dog here engaged. If I keep moving this barrel, it's in the down position. You can see it moved from all the way up. There's the dog that the teeth on there engaged with when it went down. It's moved all the way up to engage similar dogs at the top. On it. Okay, that's all the selector forks set up on this pin. 1, 2, and the reverse one is down the bottom under there. The reverse one works on this reversing gear shift change. That's that area there cleaned out a little bit more. That's the terminal that the single wire solders to. There was an O-ring on the engine side of this sensor. It became apparent once I'd cleaned off the dirt and shit around the perimeter of that. So there's an O-ring there that seals this sensor against the side of the engine and prevents an oil leak from that area. This circle here, which is now more obvious that I've cleaned the thing up, shows that that spring-loaded pin travels from here, which would be 5th gear, 4th gear, 3rd gear, 2nd gear, 1st gear, round to neutral. So that gives a wear mark, a witness mark I'd call that, as to where, and this pin being at the end of that C shape makes sense. I'm wanting to 3D print a new one of these neutral switches with some extra functionality. I would like to have some pins at the neutral point at 1st gear, 2nd gear, 3rd gear, 4th gear and 5th gear positions, and a display up on the dash as to what gear you're in at the time, as well as showing the neutral position. I think this is something that the Arctic Cat bikes have a gear position sensor, and I think it's a modified version of this one. I've taken the cable off this sensor, released that little clip and removed the cable. The cable wasn't attached to the pin anyway, and so I've pushed that clip out and removed it, and I'm going to model this piece of plastic and try and print another one on a 3D printer. Neutral and 1st, 2nd, 3rd, 4th and 5th are actually on the points of a hexagon shape. The centre line of this sensor may run halfway between the neutral point and 5th gear, and give an indication as to where other pins needed to be placed for the multi-wire connections to make this a 6-wire sensor that shows what gear you're in up on the dashboard. I'm making these brass pins here out of old wood screws, brass wood screws. It's 3mm diameter. I haven't set the length yet. I'm just roughing them out. There's the 3mm brass pins pushed in to the sensor body. They're only they're temporarily at the moment. Some of them are actually a bit loose, and none of them have been cut to length as yet. I've worked out about 16mm long is the best length. I've cut a small slot in the end of these pins with a hacksaw. The pins are now 16mm long, they're all the same. That slot is so that a wire can be laid across that slot and soldered in position so that the wire is attached to the pin like that once it's soldered. So I'm going through and doing that to all 6 pins at the moment with a different coloured wire, just for clarity. I have fitted the various coloured wires, brown to first, red to second, there's a yellow to third, green to fourth, white to fifth gear, and there's 2 blue wires there. I've attached a blue wire to go to my plug, as well as also including the bullet head lead off the original switch. That lead can plug into the existing loom, and the rest of this switch does not have to be actually operational for the neutral light to still come on. So that was the reason for doubling up on the blue wires on the neutral pin. Now I'm hoping that all of those pins are going to set flush with that surface. I need to I've put a bit of super glue on each of them, and I'm just sort of waiting for it to set so that I can be sure that they're all pressed down. I can give that surface, which is the same as this surface here, a little bit of a rub on emery cloth or something to make sure it's smooth. It's getting closer. I'm going to fit a Deutsch type plug on this end of the coloured wires. The bullet head one will be separate, and the Deutsch plug will be a nice waterproof type automotive fitting to connect to a lead that goes up to the dashboard. The slot that was in the original fitting, that rectangular slot next to the hole, is the right size for a cable tie, and so I've fitted a bit of heat shrink material over those wires, and we'll tighten that cable tie up on them. I'm fairly happy with how flush those pins are looking on this surface, and I'm happy with the connections I've made on the top there. I think they'll all fit under the cap I made. I think I need to make a little bit of an archway in the cap to jump over the cable. I'll file that into the cap, and then I may well fill the back of this sensor with some epoxy to hold it even better in the long term. Given that my first attempt at printing this body of the switch works so well, I'm proceeding with it. I expected to be printing it 3 or 4 times with slight modifications, but it's worked well so far. There's the sensor head end that I'm pretty happy with. Now at this end I've got the standard bullet head blue wire coming out the end of this bit of heat shrink, and I've got the 6 other wires, including a blue, red, green, white and brown, that are the 6 connections to the pins in the connector. I've crimped onto those some female Deutsch terminals, which are the 20 gauge ones, and I've got a 6-way Deutsch connector here. I think it's a DTM. That's the 6 pins terminated like that, cable tied as a strain relief there, and I've put a Deutsch connector on this end. I was initially showing the female outer Deutsch connector. This is the male outer Deutsch connector. I clipped female pins, terminal pins, onto my sensor, and they only go in a male outer. So rather than swap the pins to male pins to go in a female outer, I've changed the outer to a male, which that's a DTM Deutsch connector with its rubber grommet in the rear, and the wiring is numbered, sort of using as close to resistor code as possible: brown for 1, red for 2, yellow instead of orange for 3, green for 4, and white for 5, and blue, just to follow through with the original blue, is a neutral connector, and they're on the pins 1, 2, 3, 4, 5, and blue is 6 for neutral. Alright, I'll put a bit of bog in the lid there and a bit of bog around the wiring there. I'm going to press those two together before it goes off. I've got about 2 minutes. I believe this will be a more robust neutral position sensor with the extra functionality of detecting all of the 5 forward gears and neutral. Automotive standard connection there, plus the ordinary original plug. I think that will stand up on the bike very well and be a reliable sensor neutral switch going forward. And I now need to design and build the display for up on the dash and run a cable from this up to there to indicate the various gears that you're in at the time. I now need to build something for the dashboard. Get out to your shed and have some fun.